In the last video, we noted that changing the highest or lowest number on a list would not change the median at all, but it would change the mean, because of course the mean, you add up every number. And so if you change any one of the numbers, then the sum of all the numbers will change and the mean will change. Numbers far away from the center of a list are called outliers. Now this is not a term you will need to know for the test, this is just a term we'll be discussing in this video. The mean is heavily influenced by outliers, and the median is entirely unaffected by outliers. First of all, when are the mean and the median the same? Well, certainly, if the list consists of evenly spaced numbers, then the mean equals the median. Consecutive integers and consecutive multiples of the same number are examples of evenly spaced lists. For example, if I had the first 20 multiples of 7, that would be an evenly spaced list. When we have an evenly spaced list, the mean and the median are identical. So, for example, this list, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers on the list. So the mean and the median are both equal to the middle number on the list, 11. Also, mean and median are equal whenever the list is entirely symmetrical, when it's entirely symmetrical around its center. So what would this look like? Suppose we were given this list. Now, it's hard to see any discernible pattern right away. There are 9 numbers. Clearly the median is the middle number, 25. But notice the following. Look at the 2 numbers right next to 25. One is 2 greater than 25, and one is 2 less than 25. Now look at the next pair. 13 and 37 are respectively 12 less and 12 greater than 25. 8 and 42, 17 less and 17 greater than 25. And 4 and 46 are 21 less and 21 greater than 25. Another way to see that, incidentally, 23 plus 27 add up to 50, 13 plus 37 add up to 50, 8 and 42 add up to 50, and 4 and 46 add up to 50. So the point here, this would be a hard thing to see just on your own, but notice now that we've pointed out the complete symmetry of this list, we know without doing a single drop of calculations that the mean has to be entirely equal to the median, because the list is symmetrical. When the list is asymmetrical, then the mean and the median differ. So that's when you get a difference, when there's an asymmetry on the list. In particular, when there's a distinct outlier or set of outliers in one direction, one particularly high score, one particularly low score, that outlier pulls the mean away from the median. So for example, here's an evenly spaced list. Of course, the mean and the median both equal 4. Now, if we take one of those numbers, that last number, and turn it into an outlier, we replace 7 with 700. Well, we've made it gigantic now. Well, of course, the median isn't affected by all. 4 is still the middle number on the list. But now the mean is going to be much higher, because now the sum of list D is going to be much, much higher than the sum of list C. And so then when we take an average, we're going to wind up with a much higher number. If a test question asks you to compare the median to the mean, you don't necessarily have to calculate the mean. And in fact, often it's a mistake to engage in a calculation. It's very important to understand this. Often it's enough to notice in which direction the most pronounced outliers lie. So the biggest outliers, if there's a really high number or a really low number that's noticeably far away from all the other scores. The mean follows the outliers. High value outliers cause the mean to be higher than the median. And similarly, low value outliers cause the mean to be lower than the median. Here's a practice question. Pause the video and then we'll talk about this. Okay, on a test in a class of more than 40 students, the scores had mean equal median equal 81. So the scores were symmetrical. We don't know what the scores were, but they were symmetrical. 2 absent students then took the test. They received grades of 83 and 47. What are the new mean and the median? Well, first of all, notice one score is above the median, one score is below the median. And so if we add a number above the median and add a number below the median, then the median itself still is the center. So the median still has to be 81. So C and D we can eliminate, because the median is not changing at all. Now we have to think about what happens to the mean. It was symmetrical, and now we added 83, which is pretty close to 81. It's above 81, but it's pretty close to 81. And then 47, which is a really low score. Well, that 47 is an outlier. It's a low outlier. And remember, outliers pull the mean in that direction. So the mean is going to be dragged down. It's no longer going to equal 81. It's going to be dragged down below 81. And so B is the answer. The new mean is below 81, while the median remains at 81. In summary, if all the numbers on a list are evenly spaced, or if the list is symmetrically distributed, then the mean equals the median. Outliers pull the mean away from the median. We often can compare the mean and the median, or infer which got bigger or smaller, without calculation, purely by observing the direction of outliers.